The new Demerara River Bridge spans the Demerara River, connecting its east and west banks in the city of Georgetown. Its total length is 2,800 meters, and its main section is 570 meters. The bridge deck has a two-lane, dual carriageway with bicycle lanes on each side. According to the bid document, we optimized our layout based on the horizontal alignment and span arrangement. For horizontal alignment, the profile has been modified more effectively than the proposed one mentioned in bid documents by increasing the route's radius. It improved driving experience and also decreased the bridge's total length, along with the extent of its area within the mangrove, and it has limited the obstruction of water flow. Span arrangement involved increasing the main span to 300 meters, although a minimum length of 230 meters is adequate to meet the horizontal clearance requirement. Strong measures to ensure physical protection and strengthen substructures should be adopted, and both of these require subaqueous construction. This will cause our costs to dramatically increase. In addition, once dredging starts, the safety of this bridge will still be at risk. Considering this situation, we have increased the span length and located the piers in shallow water away from large vessels to reduce its collision risk level. This can reduce project investment costs, and future dredging will not threaten bridge safety. Here is our layout for the bridge. A double-plane, cable-stayed bridge with H-shaped towers is proposed for the main bridge section, consisting of a 300-meter-long main span and two side spans of 135 meters each. A concrete pie girder has been adopted for the main bridge, which can reduce materials usage compared with a regular box girder. The approach bridges adopt prefabricated T-girders, which is one of the most economical, functional, and feasible solutions. Our bridge design is inspired by local history and culture. We are trying to exemplify its spirit and beauty by incorporating it into the bridge design. The navigation light has been chosen as the bridge tower's crown. The design integrates several cultural elements, like 3 blue waves, a Victorian Amazonica lily, and the Sakik's crown to form the tower crown. At nightfall, our bridge will be like a lighthouse that helps navigators find their way and provide shelter to the city's residents. It will light up Georgetown, as well as bridge the gap between both sides of the river. This bridge is a magnificent structure that frames part of civic space. It significantly impacts every aspect of people's lives in this city to bring them joy and a sense of belonging. The proposed new Demerara River Bridge is about 2.8 kilometers long, including the construction of the main bridge, the east and west approach bridges, the toll station, the ancillary buildings, and relevant E&M facilities. The beam fabrication and storage yards, material stockyards, rebar processing plants, concrete batching plants, and filler batching plants are set on both sides of the river. 2 wharfs are leased for construction on the east and west bank. The construction of the main bridge and 2 approach bridges will be conducted simultaneously. To shorten the construction duration, the construction of the bridge is divided into 2 individual sections, the east and the west sections, separated by the closure segment of the main span of the main bridge. Besides the bridge itself, a new trestle will be built along the route of the proposed new bridge to assist in the construction of the new bridge. In addition, steel pipe piles and bailey beams are applied for the trestle structure, which is constructed using the fishing method from the banks towards the 2 main towers in the water, and it is split up between the towers to provide the main and auxiliary temporary navigation. Foundation construction. The underwater board piles are constructed using the steel trestle and the overwater construction platform. Steel casings are positioned and driven based on pile foundation setting out, with a reverse circulation drill deployed for construction. After the completion of pile foundation, brackets are welded onto the permanent steel casings. Cross members are erected and the bottom formwork is built for pile cap construction. The main bridge construction. After the pile caps are constructed, the concrete pillars of main towers of number P40 and number P41 are continuously constructed, section by section, using a stiffened framework combined with hydraulic climbing formwork. The maximum pouring height of each section is 6 meters. The lower cross girders are cast in place using supports. Segment number 0 of the girder is constructed with the in situ casting with a support system. The rest of sections are cast in place with the symmetric cantilever method, using guide traveling carriages with the stay cables erected and pre-tensioned simultaneously. Side span closure is performed first. Then, the rest of unbalanced segments are cast in place with the single cantilever method until the bridge is closed at the mid-span of the main span. The approach bridge construction. The T-beams of the approach bridge are prefabricated at the prefabrication yard, transported by girder transporting vehicles and erected by girder erecting machines from both banks towards the main bridge at the same time until completion. The deck diaphragms, construction joints, etc. are constructed with the formwork hanging method, span by span. The deck and E&M works are carried out after the completion of bridge structure. We commit to providing a safe, effective, and environmentally friendly construction scheme to ensure the successful completion of the mega project with high standard for the ease of transportation for residents and development of the economy of Guyana.